Hello class 6, welcome back to the physics class again. In our last class, what we have studied, we have gone through our overview of matter and how it is made up of. Now today we will study about the state of matter. Now before going into it, we will discuss a bit how much we have studied so far. Okay, so what is matter in a nutshell? So anything which contains some space and have definite mass in it, we call it a matter. Now how these matters are made up of? It is made up of fundamentally two particles. First one is atom. Atom is the tiniest particle where it is incapable of existing freely in the nature. But the interesting thing is this, atom contain all of the property of a matter into it, but it is unable to exist freely in the nature. So what happens? Two or more atoms collided and compiled together to form a bigger particle, which is we call a molecule. Now molecule have also all of the quality of a matter into it, but it is able to exist freely in the nature. Now what happens? These molecules, all this together form a bigger or smaller any kind of matter. Okay, so whatever the property of a molecule, it will be the property of the matter itself. So firstly, there are four important properties of a molecule. Firstly, it is tiny particle, very tiny, microscopic. We cannot see them in open eyes. We need microscope for that. Number two, it has two molecules have intermolecular space in between them. Okay. Number three, two molecules, though they have space in between, they are attracted to each other and they will not go apart without extra force or any kind of breaking the bond. So they are bonded together. Okay. Number four, they are capable of undergoing some random motion that we call Brownian motion. They are always in a state of motion. Okay. Now all these four property, this will contain in a molecule and that will be the determining factor of the state of the matter. Now coming to the state of matter, there are three states. First one is solid, liquid, gas. We know the example of solid be a duster, liquid, water, every day we drink and see, gases, all this air is a gas, oxygen is gas, all that. Now we will differentiate these three states of matter based on these properties. These all properties are included in them. So they are called parameters. All these parameters are based on all the four fundamental properties of the molecule. First one is arrangement of molecule. How this arrangement is going on? Arrangement goes on based on the intermolecular spaces in between and the intermolecular forces. Now let's take an example. Say these are 4 and 5 molecules stick together. They have some space in between. They are not totally stick together. They have some space, minute space, but some space are provided. Now when we are drawing the liquid, how it will be? The molecules will be far apart. In case of gases, they are farther apart. So we can understand from there that the arrangement of molecules are compact. Here, in case of solid, they are compact, or we can say they are tight. In case of liquid, the arrangement of the molecules are compact but less than the solid. So, less tight we can say, or loose. In case of gas, obviously we can see that all these are very loose and they are farther apart. So the arrangement are loose. Now point number 2. Intermolecular forces. Now you have to understand, when say two marker I have taken, these are two markers, right? They have intermolecular, these two are molecules. Intermolecular spaces are provided in between. Now, more the intermolecular spaces, less will be the attraction, right? Similarly, so more the space, less the attraction. Less the space, more the attraction. So what it will be in case of solid, the intermolecular attraction will be more. In case of liquid, it's less than the solid, but more than the gas. And in case of gas, this is least. Okay. Now, talking about the motion of the molecules. We have already told there are a tendency of the molecules to get in a motion constantly. So, in case of solid, what happens? Obviously, the tendency will be there. But as the molecules are tightly compacted together, what will happen? They will shake, keep on vibrating within a place, that intermolecular space, that how much intermolecular space, least intermolecular space that is contained or given to them, they will vibrate within that position only. So the motion of the molecule is pretty less. They will keep on vibrating within a limited area. In case of liquid, the motion of the molecule will be pretty free and more than solid, and it will be what? It will be within the container. Within the container and more. And in case of gas, when we are talking about the motion of the molecules, the maximum or most they get a lot of space to vibrate. They can vibrate freely and get diffused, or they move in the they take up the whole of the space, right? So now talking about the shape and volume. Solids have a very clear idea that solids have definite shape and volume, right? It has a shape. This marker is a solid because it has a shape and it has some volume in it. Volume what? The mass that is containing the space. Okay. So the matter is containing the space, there comes the idea of volume. Now in case of liquid, what happens? They don't have definite shape, but they have volume. Obviously, they are contained. They take the shape of the container where you put the liquid, right? So they do have volume into them, but they don't have any definite shape, but has volume. Okay, now in case of gas, they neither have any shape or any definite volume. Now then, let's talk about the rigidity. What do you mean by rigidity? Means how much compact or tightness is there within the molecules. So in case of solid, it is pretty rigid. So we can say this is rigid. And liquid are non-rigid in nature. Gases are obviously again non-rigid. Now talking about the flow. What we mean by flow? Flow means if the state of matter have more intermolecular spaces, more they will flow because they will have a fluidity into them. So a solid, they cannot flow normally because their compaction is more. So minimum no flow. In case of liquid, they are fluid and flow. Or we'll say flow is absent, this is present, and present in the gas. Okay. Now talking about the compressibility, what this stands for. Compressibility means if we are trying to put all the molecules together, how much they are compact or their tightness, they are arranged. Okay. So compressibility, how much we can compress a solid. It is already compressed, how much we can compress it. So compressibility is least. In case of liquid, we can compress them but more than solid but less than gases. So more compressible they are, and the gases are most compressible because all the molecules are so scattered, their intermolecular spaces are so wide that they can be put together, they can be more compressed to put together in a one place. Now talking about the surfaces, surface means how much all the shapes, when a matter gets its shape, it gets its surface, right. So in case of a marker, it has a surface. When a matter have a definite shape and size, it gets a surface. It can be more than 1 or 2 or 3, it can be many. So in case of a solid, the surface can be many. While in case of liquid, when a liquid is flowing, how many surfaces it have? It only have one free surface. Only one free surface. And in case of gases, it does not have any free surface. No free surface. Then comes the pressure. It's not the pressure that we are putting into them. It's how much they are putting the pressure and where they are putting the pressure. Solid is putting the pressure in the downward manner toward the earth, gravity. So the pressure will be in toward one surface, one direction. In case of liquid, the pressure will be toward the container, toward the surface of the container. Surface of container when it is contained. And in case of gas, the pressure will be in all of the direction. They can put pressure in all of the direction because they are easily expandable. In all direction. Now thermal expansion means when we are applying heat into something, it has a tendency, or something means the molecule especially, it has a tendency to expand, to increase. Okay. So when we are applying heat to the solid, what happens? Their compaction is so tight, their intermolecular force is so tight and so compacted that least thermal expansion happens. Okay. And so that significant, how much change, it is determined by how much change we can notice after providing the heat into them. So in case of solid, the thermal expansion is less. When we are applying heat to the liquid, the thermal expansion is more. It has the ability to scatter more than the solid. more. And in case of gas, it has the maximum expandable capacity. After when we are providing heat to the water vapor, when the temperature rises, all this, it has a tendency, the heated air has a tendency to go upward because the thermal expansion capacity is maximum. So most. Now talking about the diffusion. Diffusion means a tendency to get scattered basically. So if I am keeping this marker out here, it is not going to get vanished unless I steal it, obviously. So the compaction between the molecules, it is not going to get reduced. So the diffusible capacity is minimum. So in case of solid, the diffusion, the molecules, they are not diffusing in different direction in their own wheel. So this is minimum. In case of liquid, the diffusion is more, while in case of gas, that is maximum. If we are talking about liquid and the diffusion, I can give you another example of pond. Let's say about pond. We have seen water filled with inside it, and during summer what happens, if you will notice, the level of the water gets reduced naturally. How? The more the temperature rises, so it gets naturally converted, the water naturally converted into the water vapor. So and then it diffuses in everywhere. So we can say from there that the diffusible capacity of the liquid is more than the solid but less than the gas. Obviously, in case of gas, you have seen perfume, right? Perfume is a gas and it scatters. That's why we get the fragrance. Understand? So this is it about the state of matter, and I have talked about how they are different from each other. So this is it for this class. See you in the next session. Thank you.